Hello, who am I? Who am I? I'm Sander Mangel. I work at Fit4Me. We sell food supplements. I co-organize Magento Netherlands, the Magento Unconf in the Netherlands, 25th of August. You should all come. Mage Tech Day together with David. Where is David? Oh, he's probably in the back somewhere. Anne Vogel and Marius. I do a lot of community stuff, and you can follow me on Twitter, LinkedIn. I don't really use it, but you can follow me there. And GitHub, I have some code there. So, it's 2017, and finally, after years of having our own monolithic code bubble with deprecated technology and whatnot, we finally step into this new future of all this cool code stuff. We have Magento 2 running on Symfony components on Zen Framework 2. Finally, we can use Composer. We can use a vast array of libraries crafted by the PHP community for us to be there at Magento, and we can wield those for crafting new web shops. And for me, it has been amazing. Last couple of, I guess, 2 years now it's out. All of a sudden, we can start using new technologies like dependency injection or even Composer and unit testing. But the best thing is that we can also catch up with the rest of the PHP community with development and a lot of new concepts that they're using. And one of the coolest concepts out there, for me at least, was Headless. So I tried to do a bit of research before this talk. I read a lot about Headless, but not that much about the history of it. And actually, I couldn't find a lot, to be honest. It started off in Linux and Java. There's not very much publicized about it. And the things that are publicized about it, they're not very practical because it's more or less a concept. It's not really, there's no, you should do this or that to do Headless. Though the Drupal community did a lot of cool blogging about this. They're actually using it a lot for the new Drupal, and I can recommend the blogs by Dries Buitaerts, I think you pronounce it like that, and Joel Koenig. And also Magento's very own Alan Kent has written about it. My slides will be online and you can collect those links, and it's worth a read. So what is Headless? This image does a pretty good job in explaining what it actually does. So back in the day when we started, we did HTML, and HTML was shown in a browser. Not a lot of magic about it. And then we moved on to having databases and PHP and rendering pages, all fairly tightly coupled, probably in one script with HTML and PHP meshed together and stuff like that. We've all done it. And then someone thought, maybe we should do it in another way. Database with PHP logic, and then a decoupled front end that actually renders the data that we're getting. And that's fascinating because it means that you're no longer dependent on the front end that Magento or Drupal is offering. You can do whatever you like yourself. And that should sell you on Headless, I guess, because there's a solution out there ready to go to get rid of Knockout.js. And actually, Ricardo will talk about that later. So this is not Headless per se. This is decoupled. It's still focused on one client using APIs offered by one server. So one front end and one Magento installation. Headless, to be effective, should go further. Headless architecture means an application offering APIs to abstract away business logic for a multitude of clients to consistently and repeatedly execute the same task, which translated means that it doesn't matter if I have an app or a web shop or even a smart fridge. The way it will, for example, add a product to cart, calculate the price, fetch some more information for that, should not depend on the client using my APIs. It should depend on the way the API is implemented. The developer of this client should not have intimate knowledge of the Magento pricing engine. And that's the most important part about Headless. So, putting that into practice. One of the most fascinating things for me about e-commerce is all the moving parts, where you normally have a web shop with a contact form, or a website with a contact form. Now you have a web shop that has shipments and orders and all kinds of integrations for payments and whatnot. And at Fit for Me, what we do is we primarily work with subscriptions, which means that our clients never come to our web shop. We basically have a system that sends them out products every 6 months. And there's a host of automated services around that to actually make sure that the information needed to create an order or to make a payment gets sent out. And if people don't pay, we make sure they get reminders. So we moved away from having a very important front end to more having the business logic in the back end, which is serving our customers. So, sources, what we are talking about. We have Agent for payments, we have SendGrid for emails, we have Freshdesk for our tickets. When clients call us, we create a ticket from that. Montepacking, that's our fulfillment partner to ship packages to all those countries we serve. And we have Exact, which is an ERP system that holds stock information, that holds transactions. And Asterix is actually our integration with a VoIP implementation. And those are just a couple. We did a quick drop, and we're doing a lot of integrations. And for most of those integrations, what we did, we went online or we went to our account manager and we said, hey, we have Magento and we want to connect that. And do you have a module for us? And they were like, yeah, sure. We have a module. Install that and it'll work. And what it does basically with all those is extend a customer entity or add a table there or maybe change a few columns in the order table. And at some point we started to notice that it's getting very heavy, especially with all those automated processes we're running. We're talking about tens of thousands of lines of transactions coming in each day, mutating all the various orders we have, for example, and we noticed that stuff was slowing down. So our clients, in this case, was a fulfillment dashboard that logistics needed to see what was going on with the orders. And we customized the way we display customers in the backend for almost 40 to 50 agents doing work in the backend daily. The Magento frontend, we still need to serve out some information there. And well, basically, tables were locking. You were waiting for 5 or 10 seconds to search for a customer by name, for example, in the grid in the backend. It was pretty much unmanageable, and at some point, adding hardware isn't the solution anymore. So we took a different approach. After adding the third server for the database, we kind of figured that this wasn't going anywhere. So we decided Magento will be separated from the backend that is actually doing all the, or the front end where people are searching. We are going to pull out a lot of these heavy tasks, and we're going to make sure that Magento stays lean and mean to do what it should do, which is sell products. So implement a basic data warehouse where we can store all this data that's going on, orders, transactions, customers, you name it. which is fed by and queried by several services that are outside of Magento, not modules anymore, but outside of Magento, and that have nothing to do with Magento. To keep it simple, we'll isolate the data and the business logic that we need, and we'll make sure that every service has a single purpose, so it's easier to maintain. Which basically looks something like this. We have our clients to the left, which is Magento frontend, admin, and, for example, dashboard, but also an app coming up. We have an API gateway to query data from our databases. And we have a host of services that are fetching data not only from Magento itself again, but also from the connections that I previously described. So the services normally would be Magento modules, but we're taking them out now, and we're making sure that they're on their own server and they're not bothering the web shop. If you do it very simple, we have a source with data, which could be an API or an XML or CSV or whatever. We have a consumer, which is a service that processes that data. It's the only thing it does. It's a source where we put all of our business logic to mutate data and to make sure it gets normalized. It gets stored. Then we have an API gateway to serve it to our happy client. So normalize and combine the data. Offer stable APIs for our clients to make sure that all the services that we run for our colleagues, but also for our clients, stay fast. And this way we can also insulate from future changes. Because this, what I just drew, is on Magento 1. And to be honest, if we didn't move things to services, going to Magento 2 would be impossible. It would be thousands of hours of work just to refactor all that custom code we did. This way, when you make sure your business logic is outside of Magento, you basically just need to do a new installation, slap a template on it, and you're ready to go, theoretically. But isn't this all a lot of like rocket science for something pretty simple? I mean, a module isn't that bad, right? Where we're talking about tons of lines of code and extra servers and you name it. Actually, it's not that complicated. And I don't want to hear about not being technical enough, so let's continue to the code. Processing the incoming data. I will show you an integration we made at Fit4Me. It's not really functioning software, it's more like a boilerplate we use to grab various components to start building our services. There are a multitude of ways to do stuff like that. You could go for PHP, Java, Python. We decided to go for PHP. Simply because our developers know it already, so there's not a lot of effort in reschooling people. We decided to keep it lightweight and make sure that we use libraries. So not reinventing the wheel ourselves, we try to build as much on libraries as possible. The code is online on GitHub, and you can use it if you want or give feedback on it. So what I said is we're building on libraries, and you don't need that much to build a very powerful service. We have a fulfillment service that is doing a couple of hundred orders per minute, and we tested it up to 12,000 orders an hour, I think, running on a $10 server, actually, on PHP. We're using PHP 7. We're using Slim, which is a beautiful framework that is very lightweight, that has some dependency injection and some routing. I can highly recommend to use it. Monolog for logging. Cache file system adapters. It's a standardized way of caching, actually. It's very nice. Guzzle HTTP for querying APIs. An array cache adapter. Let's say you have a lot of data in an array. This is a simple way to smash it together and have it ready for the next time you need to query it. Illuminati database, that's from Laravel. It's a personal preference. You can also use Doctrine. I really like the eloquent library that Laravel offers. And insert on duplicate keys, make sure that you can do just that with Eloquent. Symfony console for cron jobs, so we call a console method to have an easy interface. And actually to connect to Magento 1, the PHP League OAuth 1 client has a ready-to-go integration with Magento. Which is that. So the structure, we kept it fairly simple. There's not a lot of MVC going on or separation of libraries or whatever. We have a source directory that has all our custom code. We have a couple of files that are needed by SlimPHP to do routing, etc. I think if you ever work with Symfony or Laravel, it should be pretty obvious what everything is doing. But the point is to try and keep it simple when you're building a service like this. You don't need very complicated stuff. Storage for all the data that we're processing and that we just normalized. There were a couple of options. We looked into Google BigQuery, and we looked into Redshift from Amazon. Very nice solutions. They offer SQL syntax, so we should all know how to work with it. The Google BigQuery one has a little bit more complicated way to actually connect to the server. Redshift is a PostSQL database, and you actually just fill out the host and you're ready to go. But for a prototype, what we try to do at First for Me is always work in a prototype way. So first build something lean and mean, and then let it evolve to something more complicated. So for the prototype, we ended up going for MariaDB. It's pretty lightweight. It's a drop-in replacement for MySQL, but it does offer a lot more power when it comes to searching, for example, and the way it caches. And we're talking about less than 1 terabyte of data that we're expecting to host, so it was a good solution to start off with. And we're using Elasticsearch. Even though MariaDB is good with caching and searching, nothing matches something like Elastic or Solr to do that. And by offloading all the queries we're running to find a customer with a certain name or find a Polish customer with a funny little troll under his name, we make sure that the MariaDB never locks up too much, which is very important. And then we need to expose all that normalized data that we have in the database. So for Elasticsearch, they already have ready-to-go REST API, so you don't need to do anything with that. Sure, we could add an extra layer to make sure that it never changes, but it's not really worth the effort. But for the Maria database, we did need a layer to expose all this data. So it should be read-only. All our APIs are read-only because we have the processors to work on the data, and the APIs are just there to expose it to our clients. It should offer sorting, filtering, and a host of other query options. It should be very fast, and it should be standardized and easily scalable. And with that, I actually mean that no matter if I have one table or a multitude of tables, it should be easy to add them. So as I said, search will do via the REST API. And what we're actually doing is per table, we'll make also a mirror in Elastic. And we just put in there what we really need, like a customer first name and last name, and maybe an email address or address. We don't need all of the data. What the Elastic layer returns is a UID that we use in the MySQL database per row to reference to it. So Elasticsearch should never return too much information. And for the MySQL database, we used a simple framework like I showed before for processing the data, which uses Nginx PHP 7. It does not have any business logic. It should just expose the data that you want to use. So what I said is we're using UIDs, which is a great way to represent data in a fast way. You don't want to use joins or whatever because it'll just slow your API down. What you want to do is have people query multiple times if they want more entities. That's fine. It's always faster than doing complicated MySQL queries. So, to summarize, that's it. It's not that hard to build something like this. If you sit down for it, within a week you can have something like this up and running. And it really does take off a lot of load from your Magento solution, and it offers a lot more value than slapping on some more hardware. I do hope I was able to maybe inspire some of you to try this out because it's worth it. And keep it simple. Use lightweight frameworks. Don't go off using Symfony right away because you think it has a lot of nice tools in it. Really think about what you're actually trying to build. Now that we're using Magento 2, all of a sudden we have all these options again, and again you see people falling back into the same old Magento 1 stuff they were building where we're trying to reinvent the wheel, but try to discover what's already out there. And that's it. You can read my talk online and find the code on GitHub.